Identify and find all possible rational zeros of a function. If a polynomial is a polynomial function with integral coefficients, so integers, then every rational zero of the polynomial is of the form p divided by q, where p is a factor of the constant term, that's the number term, and q is a factor of the lead coefficient, the first value with the highest degree. Okay, so let's look at this. So it says to make a list all possible zeros of the polynomial x cubed minus 2x squared plus 5x plus 12. So we want to find p, which is a factor of the constant. So the constant is right here. This is p with its factors. The lead coefficient, 3 is the highest power, so the lead coefficient would be 1. Okay, this is q. So we want all the factors of 12 divided by all the factors of 1. So if we list all the factors of 12, we'd have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. The only factors of 1 are plus or minus 1. So if I do the division, I would get 1 divided by 1. So here is my list. 1 divided by 1 would be plus or minus 1. Well, we know they're all going to be plus and minus, so let's just make a set that are all plus and minus. So plus or minus 1, 2 divided by 1 would be plus or minus 2, 3 divided by 1 would be plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So if we have rational zeros, so zeros that are fractions, or whole numbers, as in this case, they're also rational, this would be our possibilities. So this is our list of possible rational zeros, and that's all they're asking us for. So let's try that on the second one. Okay, so if we look at our lead coefficient, it is a 2. Remember, this is q. Our constant is our 12. So that's 12, that's p. So we want all the factors of 12 divided by all the factors of 2. Okay, so again, we can list all the factors of 12. Again, they're all plus and minus, right? So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Factors of 2 are plus or minus 1 and plus or minus 2. So those are my factors. Now I'm going to make my list of possible rational zeros. So my list has to be, of course, 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, 6 divided by 1, and 12 divided by 1. So we're going to make that list. 1, 2, 3, 4, 6, and 12. Okay, now remember, we also have to divide by this 2. So I'm going to go 1 divided by 2. So that is going to be some more. So that's going to be a half. And then we're going to go 2 divided by 2, but that's 1, and I already have 1, so I don't have to write it again. Then I can go 3 divided by 2. And of course, 4 divided by 2 is 2, and I already have that one, so I don't need to list it. 6 divided by 2 is 3. I already have 3, so I don't have to make a list again. And 12 divided by 2 is 6, and I already have 6, so I don't have to list that again. So with the 2, I have 2 more possibilities, plus or minus 1/2 and a plus or minus 3/2. So again, this is my list of possible rational zeros. All right, let's flip over. All right, so now we're asked to find all the zeros of the polynomial. Now remember, the easiest way to find all the zeros is to make a graph, but also remember that we still have this list that we can make. So we can have all the factors of 3 divided by all the factors of 8. Okay, so factors of 3 would be 1 and 3, and again, they're all plus and minus. And factors of 8 would be 1, 2, 4, and 8, and again, all plus and minus. Okay, so our possible zeros would be, making a list, 1 divided by 1 is 1. 3 divided by 1 would be 3. 1 divided by 2 would be 1/2. And 3 divided by 2 would be 3/2. 1 divided by 4, so 1/4. And 3 divided by 4, or 3/4. 1 divided by 8, or 1/8. And 3 divided by 8. So this would be my list of possible zeros, if they're rational zeros. Okay, so let's do a quick graph. So if I already have them inputted in here, so I'm just going to turn the first graph on, and we're going to graph this. And let's see how many rational